Hello everyone, myself Mantusha Hassan, and today the topic of discussion is significant figures. Based on the last video on which I tried to explain the units and dimension topic, there were a lot of reviews on that, and I have heard from someone that they want me to make such videos more on chemistry as well as physics also. I'm starting with significant figures today. So, what do you mean by significant figures? Significant figures are certain digits plus one doubtful digit. For example, we have 1, 1 and 6. So 1, 1 and 6 are certain digits and 4 is the uncertain digits. So what is significant, which is actually certain and which are not related to the decimals. Now what are the rules for reporting the significant figures in a number? Because in our exams there comes the question of how many significant figures does this number has. So the first rule is all non-zero digits in a number are significant. For example, we have 44.3, or we can say 12500. All non-zero digits in a number, they have three significant figures, or they have such significant figures. For example, 44.3 has how many significant figures? Three significant figures. 5.243, it is a non-zero digit, so it will have four significant figures. 41.124, it will have 5 significant figures. Next, so a decimal point does not count towards the number of significant figures. So first rule is clear. I hope that all non-zero digits in a number are significant. 44.3, 48.6, 49.6485, so they are significant. Now next, second rule, the zeros between two non-zero digits are always significant. For example, this is a number and the zero comes in middle of these two numbers, 6.01. तो ये middle में आ रहा है, so it will have three significant figures. 6.001, so the zeros inside zeros are always significant. So 6.0001 is how many significant figures? 6, 1, 2, 3 and 4 significant figures it would have. Now the third rule, it says it is important now. Zeros written to the left of the first non-zero digit in a number are not significant. They simply represent the position of the decimal point. For example, this point after the decimal we will count the significant figures. 0.523 written to the left of the first non-zero digit are not significant. So 523 has how many significant figures? Three significant figures. 0.0014, so significant figures are only two significant figures. 0.002, how many significant figures? Only one significant figure. So it is the most important rule that the zeros written to the left of the first non-zero digit in a number are not significant. Now rule number 4, all zeros placed to the right of a decimal point in a number are significant. For example, we'll discuss it with a new thing, that is 11.0. Now this point, this decimal point, after this decimal point there comes the zero, so it will be counted 11.0. that means how many significant figures? Three significant figures. 11.00, how many significant figures? We have four significant figures. In short, we can say SFS. The reading may be 11.0. Now the zero which comes on the right of the decimal point, they are significant. So how many significant figures will be there? 1, 2, 3, 4, 5 significant figures. So I think these 4-5 rules are clear. Now the order or a power is not significant. For example, if we say 4 into 10 to the power 6, so 10 to the power 6 is not significant, it is not counted. Okay, next we have exponential notations or scientific notations. You have to write 40400.0. so if you have to shift it to the right or to the left, then what happens? If we shift it to the left, this decimal point is shifted to the left to 1, 2, 3, 4. So how many significant figures it has? 1, 2, 3 significant figures. So it should have only 3 significant figures as well. So 4.04 into 10 to the power 4. Next we have 0.000404. If we are moving this decimal on the right hand side, then what will happen? There comes a minus power. So 1, 2, 3, 4, 5. 4.04 into 10 to the power minus 5. So I'm asking a superb question now. 0.000054, it has how many significant figures? zeros are not counted, so it has only 2 significant figures. But if we have to express it in the form of scientific notation, then what we have to do, 54 multiplied by how many numbers, 1 2 3 4, so it will be 5.